Welcome to the next section, Random Access List. In this section, we'll see a list implementation that provides efficient lookup and update operations, in addition to the usual head, tail, and cons operations. First, we'll look at how to increment a binary number. Next, we'll learn how to add two binary numbers. We'll use the insight thus obtained to design a random access list, a list of binary trees. Note that all binary trees roots are linked. We'll look at the elements insertion, lookup, and update algorithms. Let's step ahead to the first video of this section, incrementing a binary number. In this video, we'll learn to add two binary numbers and increment an empty list. Lists are great when we are prepending or matching at the head, having big O of 1 complexity. However, as we saw, lists don't perform well when it comes to random element access. Accessing an element at the nth index has big O of n complexity. Before we jump into list implementation, let's look at the related binary operations. First of all, let's see how we would increment a binary number represented by a list of 0 and 1. Define an increment function with numList for integers. We match the number list. Now, write the case clause. The case nil for list of 1, case 0 for XS, and case 1 for incrementing XS, and the last case if no binary number is found. Note that we need to write the numbers such that the least significant bit is on the left-hand side. When we wrote the binary number algorithms, we saw the reason for it. We wanted the LSB to appear at the head of the list. Operating at the head of the list is a big O of 1 operation. The increment method has 4 case clauses. The first one, and the simplest, is when we increment an empty list. We define this operation to yield list 1. The second clause adds 1 to a number that ends in 0. Remember the need for reversal. For example, consider we're adding 1 to any binary number that ends in 0, such as 1000, that is decimal 8. Here, we just replace the LSB 0 with 1, yielding 1001, that is decimal 9. The third case is when the LSB is 1. Adding 1 to 1 results in 0 and a carry. So we recursively call the increment function again with the rest of the list to account for the carry. A carry is really adding 1 to the rest of the list. The last clause is a catch-all. It's an error to pass anything other than a sequence of 0 and 1. Let's use this method in REPL. Increment the list 1, 0, 1. You can see the incremented list in the result. Now, if we try to insert the same list again, we'll get the same result. Let's try some other values, say 0 and 1. Now the list is incremented as 1, 1. Let's take another example with values 0, 0, and 1. The incremented list is 1, 0, 1. Now let's look at how to add two binary numbers. We define a function add with two integer lists. Next, we write the case clause. The first one when both the lists are empty. The second case when the first list is filled and the second list is empty. The third case when the first list is empty. Similarly, we write the fourth case, fifth case, and sixth case. I'll explain you these in details. And the last case when a non-binary number is inserted in the list. Done. The first 3 clauses are simple. If one of the lists is nil, we return the rest. If both are nil, we return nil. This clause matches when both the lists are non-empty and the second LSB is 0. In this case, we just tack on the LSB of the first list, which could either be 0 or 1, and add the rest of the numbers. This is the same as the fourth clause from before. The difference is just that the LSB of the first number is 0. It's handled in exactly the same way. This is the final clause, which is hit when both the LSBs are 1, As we know, this results in a carry. We take 0 and add a carry to the rest of the number's addition by incrementing the result. Let's see how we can use the addition method. Add list of 1 and list 2. Here we're adding 1, 1, that is decimal 3, to another 1, 1. The result is 0, 1, 1, which, when reversed, is 1, 1, 0. This means we have decimal 6. Nice! In this video, we saw how to increment a binary number. In the next video, we'll learn about list of tree roots.